Page 42, we'll fill in our title block here very quickly. And our topic is called solids in contact. Now, in the question we are given the plan view. Very important to note that. And this time, guys, we're probably going to have to draw it in the middle of the page, and I'll show you why we're going to draw it in the middle of the page. You're only going to fit one on this page probably. So, draw it in the middle and label your XY line. Okay? I'm going to step down by 10 millimeters from the XY line. It doesn't give me a measurement, so I can make it up myself. And then I'm going to draw my square based pyramid. That's going to be 52 millimeters in diameter or in size. Okay. So measure 52. This is drawn with a 45-degree set square. It's supposed to be yes, because that's what's given to you.
Do you mean the green ones that my box at home?
Yeah, in there. In the press, yeah. Now, there is the plan view of my square base pyramid. What I can do is I can try and draw the elevation of that also. So I'm going to bring up my base points. There is something that I'm going to want you to start to do in this question, and that's to label it. Okay? So I'm going to label each corner here A, B, C, D, and O for the pyramid. Okay? O is going to be the top point. Sorry? Solids in contact. Okay, reading the question in the book, it tells us that the height of the pyramid is 58 millimeters. That's described as the altitude. So I'm going to step up 58 millimeters. Again, using sharp equipment so that we can get accurate points. And that is my pyramid. So I have O is up here, B is there, A is at the back, C is at the front, and D is on the right. And there's nothing more that I can draw at the minute for this question. Okay? Now, by reading the question, it says that the sphere is 24 millimeters in size. Okay? It's 24 millimeter in radius, apologies. And it's down here somewhere, but where do I put the center point? I don't know, it doesn't tell me. So this is something new that I want everybody to learn, okay? We're going to do an additional view. Now I'm just going to show you this very, very quickly with a little model. Okay, just let me get my pyramid, and then I'll be able to explain it. Okay, so just to explain this to you, this is what we call a truncated pyramid, okay? Now, can we pay attention here, guys, please? Okay, that's essentially what we're trying to draw. I have a sphere and I have a pyramid, okay? I don't know where this center point goes. If I change the sphere, the size of the sphere, the point of contact between the two objects is going to be different. So this sphere is slightly bigger, and if I replace that with a different size, the point of contact is going to be different. Now, this question is slightly different because it's different than the ones we've done, because we have been given the radius of the sphere. In the previous two questions, we were not given the radius of the sphere. Just another example there. The point of contact is going to be a little bit different again. If I keep increasing the size or decreasing the size of the sphere, my center point changes, okay, and the point of contact changes. So what I want to do is I want to get a little character, or I want to take my personal point of view. Okay. So, for our front elevation, guys, we are looking at the pyramid from here. We're looking in at the front, and that's what we see up there. Essentially, if I show you that, that's where he is standing there, like that for the pyramid. And then when you're looking down the plan, that's where he's standing. What we're going to do is we're going to move around to here, and we're going to look in at this surface so that we're looking at that surface at 90 degrees. So let me just set that up. We're going to look in at this surface, so we're looking in at 90 degrees, like so. Can you see that? Does that make sense? See my little basketballer? Right? Standing there, looking in so that we see this surface at 90 degrees, and so we see that circle where? What have I been describing this as, Pietra? In the last couple of questions, I've described these two objects in what position? So where he sees these two objects, they're what? Where this little person is viewing this, those two objects or two-dimensional drawings are what? Not separate. What are they?
Side by side.
Side by side. And that's why we moved this view. In the previous question, we rotated it around because the two surfaces were curved. The cone surface was curved and the sphere was curved. So we were able to rotate the sphere around the cone. In this object, we don't have a curved surface, we have flat surfaces on the pyramid. So therefore, we have to move our viewpoint in order to see the surfaces or the objects side by side. So what we are doing now is we're creating what's called an auxiliary view. So with my 45 degree set square, I'm going to look in this direction. Okay, I'm going to view in that direction. And so therefore, with my 45 degree set square, I'm going to take C and D and bring them up there. I'm going to take O and bring it up there. I'm going to take A and B and bring them up there. I'm going to recreate the ground. So the ground is going to be positioned anywhere as long as it doesn't interfere with my image. So I know that my sphere is going to end up somewhere here and the sphere is going to end up somewhere there. So the ground that I want to draw is going to be here. It's a copy of the ground that I already have, and this is known as our x1, y1. It's a copy of the ground. Is that okay? This is known as an auxiliary view or additional view. Auxiliary is just a fancy name for a new view or additional view. Now, what is the height of my pyramid? From the question, what is the height of the pyramid? 58. So I'll measure in 58. That is point O. I'll bring O to my base points. These are my two base points C and D that I have labelled, and I want you to label them also, regardless if you understand what's going on or not. And this is A and B. This is C and D. Okay, and I'm just going to draw it in heavy so that it stands out, so that people understand what the object looks like. The object is going to be different to the construction lines. Okay? So why did I move to here? The reason I've moved around the object and looked at it at a different angle is because this object has flat surfaces and therefore we can't rotate the sphere around it. Alright, we could rotate the object, but that's going to create a lot of complication for us also. So we're not going to bother doing that. Okay, so now that I have my view from here where I see the edge or the extreme generator, if I use a little bit of colour here just to explain this, this is my this here is my yellow surface, so therefore that line is going to be my yellow surface. Just 1 second. Now, can we see that in the image? Yeah. Can you see that? Yellow surface. Yellow surface. Who has a question for me? Oscar.
How long do you draw?
It doesn't matter as long as it doesn't run off the page. And I know that a sphere, my end sphere that I'm trying to solve, is going to land somewhere here. So I want to accommodate for that. So I just want to move it out of the way so that it's not off the page, but it's not also interfering with my solution. Any other questions, guys? Keep them coming, please. Now, I know that my sphere is 24 millimeters in radius. Yes? So I'm going to use this example to you here. If I put that sphere on the ground or the table, how far is the center point from the table? No matter where I roll it, how far is the center point from the table?
0.
How far is the center point from the table if I know the radius of that? The radius of this is 24, so how far is the center point from the table? How far is the center point from the wall? How far is the center point from this surface here? So no matter if it's a sloping surface, if it's a horizontal or a vertical surface, we know the radius, so therefore the center point has to be that measurement away from that surface, yes? So therefore, how are we going to find the center point here then? Any solutions? Any solutions? Louise? Anybody, any ideas? If we know the center point, the radius, we know the distance of the center point to the outside of the circle, how am I going to find the center point here? Take your previous knowledge into consideration. Measure up 24 from where, Kira? From the x1, y1. So if I measure up 24 and I draw a parallel line to that, I'm going to use sliding set squares for this, even though it's a 45-degree line. I know the center point of my sphere has to be somewhere on that blue line. How do I know that? Because it is 24 from the ground. Is there anything else I can do? Remember, to find the center point we generally have to do 2 techniques and combine them. Or 2 steps and combine them. What's the second thing I could do, Gavin and Dennis? Don't be too worried about handshakes and let's just do this.
Finding the bisect.
I could do that, yes. I could bisect the angle, absolutely. Is there anything simpler I could do than that? Why 45 degree? So this is an obtuse angle, so I wouldn't be able to do that. Sean?
Measure it
From where?
from the CD line.
And CD's, that's a point view of that, so that's the CD line there. Does that make sense? Very close, so give me reference to colour. Yellow line. Measure out 24 millimeters from the yellow line, and then what do I do? I've measured out 24. I've only a point at the minute. What do I need? I need a line, because the sphere could roll anywhere along that surface, couldn't it? Where the center path of the center point meets the path of the center point is my center point. If I bisect the angle like you said, Mattis, I would still get the same point. But that's much quicker. Is that okay? So you could bisect the angle, which we've done in the previous two questions, or I could just take my radius and step away from the surface that it contacts, and step away from the surface that it contacts, the radius of the sphere. It gives me the center point. I can then draw my radius will come down to there, and my radius will also if I draw my normal from the tangent, both radii will be the exact same. That's or and that's or. I set my compass to or and I draw in my sphere. Now, how do I solve the rest of the question? I found the difficult part, Oscar and Dominicus, okay? I found the difficult part. Now, how do I solve it?
So, where did you get the or lines?
I created them myself. The or lines are normals to the tangents. You remember? So that's a normal, and that's a normal. Both are 90 degrees to the tangents. There are two tangents. One is the ground and one is the side of the pyramid.
So I need to do this. I wasn't
This is brand new to everybody. Literally what I'm after doing is brand new to everybody.
How do you do it?
What is it?
How do you do it?
How do you do it? Were you listening to me?
I was drawing.
Okay. So I'll explain in a second. Is that okay? Just let me finish off the question. How do I now solve the rest of the question? You better not be swinging in the chair, are you? Are you swinging in the chair? Do you realise they're over €100 to fix, to pay for? Yes? If you break it, you pay for it. So don't swing in it. Now, anybody? Answers. How do I solve it? Where are we looking for it? Read the question. What does it ask us to do? Point of contact. Yeah, so I've point of contact here. We generally don't put in the point of contact between the sphere and the ground, by the way. There is 3 points or 2 points of contact. The sphere and the ground and the sphere and the object, but you generally don't put it in between the sphere and the ground. Just to let you know, okay? So the question asks, the plan of a square base pyramid and the sphere resting on the horizontal plane are shown. They are in contact with each other. Draw the plan and the elevation of the solids showing the point of contact. Have I got either of them done? Have I got the plan or the front elevation complete? Have I? I've got the plan complete. I need to bring the circle down, don't I? Yes. So how do I bring that down here? What angle am I going to bring it down at? Dennis?
The same angle that you brought it up.
Brilliant answer. The same angle that I brought it up. And that angle was 45 degrees. So I will bring it down the exact same angle that I brought it up. Now I have my fixed center point. Now I know where the center of my, I'm going to call that C1 just because I have a C label already. I know where the center point of my sphere is positioned. So now I can take my radius again and I can draw it in my plan view. There's no need for fake spheres in this scenario. We don't need to draw them in because we don't need to rotate the object around. So now that I have that, I'm pretty sure it's a green sphere. I can colour that one in because it's the finished sphere. And now how do I finish the question off? So I have my base sphere, I have my auxiliary view, and how do I finish it off? Bring the circle up or the sphere up. How high do I bring it up? That is the question. So here's my center point here. I'm going to bring that up, but how, when, where do I know where the center point is finished? 24 millimeters up. Excellent. So from the ground we measure up 24. That's my center point, which I've called C1. I take my compass again and I redraw that in. I colour it in, trying to make it look like a sphere, like a three-dimensional shape rather than a two-dimensional shape. So in order to do that we need to use tone, shade and shadows perhaps. I'm also, I'm sketching in a curved manner so that it gives the appearance of a curved surface, something that we need to build on, something that I also need to explain to you in more detail, but you get the idea for the minute.